Alright, well, welcome to Unit 3. And Unit 3 is a lot about exponents and scientific notation. And specifically, we're going to dive right into Lesson 1 and product laws of exponents. And by the end of this one, you should be able to explain the use of power product, and product of powers, and identity of laws of exponents. That's a lot of words, right? So we're gonna just kind of talk about what exponents are, what happens when we multiply terms with exponents together, and the essential question is, like, how can the laws of exponents used to write equivalent expressions? So before we talk about expressions, let's talk about terms, and real quick review on what makes up a term, or the components of a term. Well, the minimum that you need for a term is a number. Okay, so say for instance we have like the number 2 here. Okay, and then of course you need a sign, whether that sign is positive or negative. There's a term. Okay, and then if you add a variable to it, say we have good old reliable x, for instance. X, you have, here's our term 2x, right? So there's a variable term 2x, and it's normally written, if it's the first term in a string of terms, or just the only term that you have, it's just written as simple 2x, because the plus sign is invisible, or just not written or assumed, unless it was negative 2. And similarly, if our coefficient was just 1 for this x, it would just be plain old x, right? There is a 1 in front of that x, right? It's just invisible along with the plus sign for that. So, like, just the term x is actually plus 1x, positive 1x. So it's the sign for it, the coefficient for it, the variable, and x. Okay, what also isn't shown here is the exponents within these terms, right? We have an exponent, this 2 is raised to the first power, and so this x is also raised to the first power. In fact, every number you see anywhere is raised to the first power, and any variable you see that doesn't have a specific thing, little superscript, little number above it, is raised to the first power. It's just, the only thing is that, like, if you have a number like x raised to the first power, it equals x, and that's called the identity exponent law. Okay, it just equals x. Anything raised to the first is equal to that thing, right? So 2 raised to the first is simply 2, right? Pi raised to the first is simply pi, right? Anything raised to the first is pi. So they just don't include it, and it's presumed to be there. It's just an invisible 1, right? So technically this is 2 to the first raised to 1 to the first. There's a lot going on here that's not shown, right? You just have to know that it's there, okay? But what if it's not raised to the first? Let's identify some stuff here. So, like, what is being raised to a power, and what does a power do when I raise it? Okay, well, that thing that is being raised to a power is called the base. B is the base. In this case, in our example up here, 2 or x can both be a base. All right, and we're just going to use this, and then the power is, we'll just call it p, I guess, right? P is the power. All right, so this is a base raised to a power. Okay, and what that means is this is going to be the base multiplied by itself multiplied by p number of times. All right, so that may be a little bit obscure. So let's show you an example. Say I have my 2 raised to the 5th. Okay, so base is, this is my base, this is my power, right? So I have, this is going to be 2 multiplied by 2 5 times. 5 times, right? So it's actually going to be, 2 times 2 times 2 times 2 times 2. 1, 2, 3, 4, 5 2's multiplied to each other. So 2 times 2 is 4 times 2. Well, I can actually just do like this. I multiply all this stuff together. This is 4. 2 comes down here some more. This is 16 times 2. And 16 times 2 is 32. Right? So that is, so if you see, you can even do with a calculator here. If I go 2, let me get off of radians here. It doesn't matter. 2 raised to the 5th power is 32. Okay? That's what that y to the x does. 2, and then that's the y here, my base, raised to the 5th power is, 2 raised to the 5th power is 32. Okay, I'll do that again. 2 is my y, raised to the 5th power is 32. You can see that. So that's what I'm doing when I raise something to a power. Okay? So yeah. So if I just had like an x raised to the 5th, it would just be x times x times x times x, and I missed an x, times x. 1, 2, 3, 4, 5 x's multiplied together equals x. So if I say, hey, what's x times x? Or what's 1x times 1x? Right? Or what's positive 1x times positive 1x? Well, it's plus 1 times plus 1 is plus 1. Plus 1 times x is, well, that's just going to be x squared. Okay? Or just simply x squared. Okay? So that leads to my next one. Multiplying terms with exponents in them. Okay, so the simplest form, let's just show you how I do it without, why not go, let's swing for the fences. Let's swing for the fences right at first. Let's say I have 2 terms. I have a green term, and we'll call this green term like negative 4x. Well, you can see that, so I'll color it in a little bit. Negative 4x. That's my green term. I'm going to multiply that by a red term, and we'll say I'm going to multiply that, well, I guess it's a pink term, times 3x squared. Okay, so I'm multiplying these 2 terms together. Well, what steps should I take? Well, my first step that I want to take is 1, determine the sign of what my answer is going to be. The sign, I guess. It's going to be plus or minus. The sign, plus or minus of the answer, of the product. Of the product. Okay, so how do I do that? Well, my answer is going to be in blue. All right, so what I'm going to do is I'm going to say, okay, well, a negative times a positive is a negative, right? Because remember, a negative times a negative is a positive. A negative times a positive is a negative. Okay, and anything that you do, or in a positive times a positive is a positive. The only time that you get a negative is when you have mismatches. Okay, getting a lot of focus here. All right, so there we go. So my sign of my new term that I'm making between combining these two terms or multiplying these two terms together is going to be a negative times a positive is a negative. Then I'm going to multiply my coefficients together, my big numbers, to multiply, maybe I should just write out multiply, not to be confused by x. Multiply, big numbers together. Those are my coefficients. Coefficients. Probably spelled wrong, but that's okay. All right, so what is 4 times 3? Well, 4 times 3 is 12. Okay, and then my third step is going to be add exponents of like variables together. Okay, that like variables is important. I can't add, I can't multiply, I can't combine an A and a B, right? An A to the first and a B to the second and make it like A, B. I can't, that doesn't make any sense, right? It has to be the same variable, right? Right, so then x to the first, remember this is an invisible one, plus times an x squared is going to be, I'm looking at my x's, it's the only variable I have. 1 plus 2 is 3. Okay, so that is how I multiply those terms together. So the most important thing here is to remember from this one is it's just like multiplying negative 3 times negative 4, excuse me, negative 4 times 3, right, which would have been negative 12, but you're tacking on this x here, where you have just to add the exponents. You have to add the exponents, so it would be x to the third. That's the only difference. Okay. Now, let's say, for instance, I have something inside the exponents. Like I have, inside parentheses. Say I have like negative 3x to the x cubed y squared, and I'm going to square that. Okay, I'm going to square that. You know, let's raise it to the fourth. Now we'll square it. We'll square it, make it easy. We're going to raise this whole thing. We're going to square it first, just to make it easy. Okay. What you need to know is, let's first ID the components. Okay. Well, after you verify everything in here is as simple as it can get. Like if this was an x and that was an x, right? You could have made this x to the fifth, but it's not. That's a y, right? So it's x cubed y squared. Our components inside the parentheses is this negative 3. That's our coefficient. Our x cubed, that is an x variable. And then we have a y squared, another variable. Okay, and when we square this thing, we square everything inside the parentheses one at a time. We're going to square that. We're going to square this, and we're going to square, that. Okay, with like results. All right. So first things first, squaring a negative 3 is just like squaring a normal negative 3. Okay, this is negative 3 squared. Okay, it's not negative 3 squared. This is different. And this, right, it is negative 3 squared. Okay, so that is negative 3 squared. Okay, because of PEMDAS, right? So that would be negative 9. Right here, we're squaring we're squaring the negative. And when you square a negative times a negative, negative times a negative equals a positive. So this result is going to be negative squared. It's going to be a positive 9. Okay? So I'm just going to erase that positive because this is invisible. This is invisible, right? So I'm just going to erase it. Okay? Then, so that's my red term. Now this is where it's different. I'm not multiplying two like variables together with different exponents, or same exponents, doesn't matter. I'm raising this x exponent, which is 3, to another power, which is 2. Okay, in that case, or I guess number 2 here would be distribute the exponent all components of the term. We've already done that with 3. Right, so this is going to be 1 square, Q-U-A-R-E, or raised to the power, raise to the power, coefficient, okay, and then for these here, sorry to really ring it out, then you multiply the exponents by the power. Multiply the exponents by the power, right? So that means you take this 3, you multiply it by the power, and you get x. 3 times 2 is 6. Okay. Then here we're working on y. Y 2 times 2 is 4. Okay. That's where 2 can be confusing, because if it was over here and it was 2, right, and you're just multiplying them together like this, right, it would be 4 as well. But squaring 2 is multiplying 2, and adding 2 are the same as this thing. So 2 is kind of a tricky example, which is why I threw in the 3 there as well. Okay, so that is distributing. Okay, so to kind of bring it all home here. Okay, kind of bring it all home in a summary table. All right, a power to a power. Right, if I have a power to a power, right, like a product of powers. That means I'm doing a base, times a similar base. Okay, a base times a similar base, and they have like a B, like a N and an M, right, like that. It's going to be equal to. It's going to be equal to that base times n plus m. N plus m. Even if this is negative. We'll talk about that in a later unit or in a later lesson. So an example, a really easy example, would be like 457 to the third times 457 to the 10th would equal 457 to the 13th to the 13th, like that. Okay, so there's that one. Next one is a power of a product, or a power of a power. Power of a power. All right, so if we have another power of a power here, product of powers, yep, power of powers. Okay, yeah, so a power of powers. If I have a number like a B, okay, and it's raised to an M, like this, and that is raised to an N, for instance, right, this is going to be equal to B times these two multiplied together. n times m. Okay, an example of that would be like, say it's like 5 to the third, right? 5 cubed, and all of that raised to the 7th. Okay, that would be equal to, well, 5, 3 times 7 is 21. Okay, then we have a power of a product. Power of a product. Now, I didn't really go over this too much. Okay, if I have two different things, right, that, actually, I guess I did go over this one. So if I have two things that are inside of parentheses, that's what this was, right? An A and a B, right, and it's raised to a C, right? It's going to be equal to A times B, and both of them are raised to the C. That should be burgundy or something. Raised to the C, like that. Okay, so that's kind of what is going on there. So like if I had in parentheses here, I had a 4 times a 2, 4 times a 2, right? And it was raised, it was both squared, right? This would be equal to 4 squared times 2 squared. And you can dump that into a calculator and see for yourself. Okay, and then remember, the identity exponent is anything like x raised to the first equals x. So if we have like 4 raised to the first, equals 4. Okay, so and remember, these work both ways here. So hopefully all that helps and works and makes sense. That should be enough to get you through Unit 3, Section 1.